Okay, good day, students. This is Miss Codner talking about December 15th and December 16th lesson for today. So for today's class, I had copies made that was on pink paper, which we're going to go over because we're going to deal with the topic today with systems of equations. But unlike the other classes, we are actually going to learn how to do system of equations algebraically. So we did numerically first, then we did graphically last class, which was December 13th and the 14th. And then today we're actually going to do it algebraically. So that's why we have the calculators. We have some pens and paper. And I started the class with an activity with sentence strips. So every student got a word or a phrase that dealt with an operation. So they either had to put it under addition, subtraction, multiplication, division, or equals. And every class, they put it up there, just give them a couple minutes, and then we checked over again to see if everyone was correct. And once everybody was correct, they got a form, just like the one that you're seeing before you, that says operations terminology. And what happens is all these words deals with certain operations. And soon enough, we're going to really deal with word problems. So there's a copy of this that's under the classwork as operation terminology. And it just basically hits hard on all the words that you're going to really see in word problems. So one of the things that I didn't have up on my board during the activity was the inequality section. So if you notice with the inequality section, it has these two phrases, is more than or is less than. You'll probably have seen more than and less than under addition and also under subtraction. Okay? When you just see plain old more than or sometimes plain old greater than or just plain less than, that means we're talking about the addition and the subtraction operation. But when they have those phrases is more than or is less than in front of that phrase, that means they're talking about inequalities. And soon enough, we're going to be dealing with inequalities, but I just definitely wanted to have you guys have these words ahead of time. So when we come across word problems, you'll be able to identify, okay, am I multiplying, am I dividing, am I subtracting, and so forth. So after we did that activity with our terminology, we talked a little bit about substitution. So here's a copy of Sports Illustrated back in 2005. And if I'm not mistaken, I think this was Duke. And since it's basketball season for me, it just seems like appropriate for me to use basketball lingo. So the first question asks you, how many players are in the cover at the right? So if you notice, there's basically 1, 2, 3, 4, 5, 6, 7, 8 players altogether. Okay? But in the game of basketball, how many players can be on the court at one time? So there can be 5 players per team. Okay, so each team can have 5 players on the court. So when one player comes out and another goes in, what is that called? So hopefully you're saying that's substitution. So for any sports lingo, we usually say sub for short. Okay? So when you're making a sub, one person's coming in, one person's going out. So the next question asks, when one player comes out, does any part of his body stay on the court? So if all of a sudden, okay, let me get a sub, and all of a sudden you see a piece of leg on the floor, that normally doesn't happen unless there's a prosthetic leg, but we'll talk about that later. But normally, all of the persons going in, his entire body is coming out, okay? As I said before, it's a crazy question, but keep it in mind when you're working on the algebra. So what I actually did was, for problem number 1, I had a student represent each situation. So I had a student represent x equals 3y, I had another student represent the x, the plus, the y, the equals, and the 8. So if you notice, if I look at that x plus y equals 8, those are basically the 5 players that's on the court. My x equals 3y, that's going to be my sub. Now let's think. Who is that x equals 3y? Who are they going to sub for? So if you notice, it asks you what expression can you substitute into the second equation. You can substitute 3y. And the reason for that, if I may abbreviate, because they're telling me what represents x. So from the beginning, it's saying x equals 3y. So I can actually take this 3y and substitute it in for x in the other equation. Okay? If you look at number 2, it's almost the same situation. If y equals 4x, while 3x plus y equals 10, what expression can you substitute into the second equation for y? So since y equals 4x, I'm going to substitute that 4x in for that y. So if I did this as an equation, it would look like 3x plus 4x equals 10. So now it looks like I'm solving for what variable? Hopefully you said x, because I have 3x's over here, I have 4x's over there. If I continue on, I'm actually solving for that variable x. So with substitution, when we're dealing with systems of equation, this is the other side of the paper. Well, for me, it was the other side. For you, it would be the second page. The whole purpose of solving it algebraically is we want to see when those two lines are going to intersect. What is my point of intersection? Okay? So if you recall when we were doing systems of equations and we're naming the system, I'm kind of looking to see if these two equations or the system of equations are going to give me a point of intersection or a CI system, consistent independent. So we're doing the algebra of it. We want to see what that point of intersection is. So remember, a point of intersection is your x, comma, y values. So now let's look at number 1. I have y equals 3x, x plus 2y equals negative 21. What am I substituting in for y? Or what am I substituting in for x? Looking at the first equation, they're telling me what y equals. Y equals 3x. So where I see a y in my second equation, I'm actually going to plug in the 3x. So if I wrote this out, I would have x plus 2 parenthesis equals negative 21. And inside that parenthesis will be 3x. Okay? Because I'm subbing 3x into the game, that means y's got to come out. Because remember, we can't have more than 5 players on the court in basketball. If we do, it'll be a technical foul on us. But we'll talk about that later. So now, order of operations. Please excuse my dear Aunt Sally. We don't have any exponents. We have parentheses, but we can't do anything inside them. But we do have multiplication. So 2 times 3x, that's where my 6x is going to come from. Everything else, the x plus the equals and the negative 21 is just being rewritten. So now I have 1x plus 6x. That's going to give me a total of 7x. And that's going to equal my negative 21. In order for me to find out what x is, I have to divide everything by 7. So once I divide everything by 7, those two 7's are going to cancel out, leaving me with x equals negative 21 divided by 7 is a negative 3. So right now, x is going to equal negative 3. So as I mentioned before, an ordered pair is x comma y. I found x. Now I have to find y. If I look back at my original equations, I notice that I have an equation that states y equals 3x. So in this case, I can use that equation, and I can substitute this negative 3 in for x, so I can find my y. So now I have y equals 3, parenthesis, negative 3. So what is 3 times negative 3? Y equals negative 9. So now, we found our x. We found our y. So now let's put it together. So in this case, for number 1, the point of intersection is negative 3, comma, negative 9. This is my solution to the original system. Okay? It seems like a lot. This is not your first time seeing it, but it's a long time since you've seen it. So the best thing to do is to take it step by step. Okay? I'm going to jump down to number 3. So number 3 states x equals 4y, 2x plus 3y equals 44. So now, what am I substituting in? So if you notice, I have x equals 4y. That means this 4y is going to be substituting for x in the other equation. So if I rewrote this, I would have 2 parentheses plus 3y equals 44. And inside that parenthesis, I'm writing 4y. So remember, please excuse my dear Aunt Sally. We don't have any exponents. We do have parentheses, but can I do anything inside that parenthesis? No, it's already done. It's 4y. But now I have to do multiplication. So when I multiply, I have 2 times 4y, which gives me 8y, okay, plus 3y equals 44. So now, 8y plus 3y, they're on the same side of the equal signs. Since they're on the same side of the equal signs, I can just combine them. So 8 plus 3 gives me 11y equals my 44. And in order for me to solve for y, that means I need to get rid of this 11. This is multiplication. I need to do the opposite, which is division. So I divide both sides by by 11, which gives me y equals 44 divided by 11 is 4. So y equals 4. So since we found y, now we got to find x. Again, I can use this original equation right here. So I have my x equals 4y, but instead of a y, I'm going to write a 4. So now we just have to do simple multiplication. 4 times 4 gives me 16. So I found my x. I found my y. So now let's put it together. When x comes before y, that means I have 16, comma, 4. Be careful. Even though I found y first, that y equals 4, that's still my y. So when I put it in as an ordered pair, it's going to be 16 comma 4, not 4 comma 16. Okay? So now, the next thing that I did in class was number 6. So notice I skipped around a little bit. So for number 6, it looks funky, but is there an equation there that I can just substitute? I have 4x plus 5y equals 11, and y equals 3x minus 13. So hopefully you see that this 3x minus 13, I can substitute that for y in the other equation. So this is going to go along with what I mentioned about a player going into the game. So when a player goes into the game, the whole of his body is going into the game. The same way as when a player is being substituted out. All of his body is coming off of the court. So it's not just the 3x that's going in for our y. It's the 3x minus 13. That whole term, that whole expression is going in for y. So if I rewrote this, I would have 4x plus 5 parenthesis equals 11. The parenthesis is basically representing what I'm substituting in. And I'm substituting in my 3x minus 13. So now, please excuse my dear Aunt Sally. There's no exponents. There's something in the parentheses, but can I combine 3x and negative 13? No. Because remember, the 3 has an x associated with it. The 13 does not. So since there's no x's other than just that 1, I can't combine those two inside the parentheses. But what I can do is I can distribute. So when I distribute, I multiply. So 5 times 3x gives me 15x. 5 times a negative 13 gives me a negative 65. Everything else is coming on down. My 4x, my plus sign, my equals, and my 11. So at this part, I noticed a lot of students were like, okay, let me subtract 4x on both sides. So they were doing exactly this. This is incorrect. The reason why I'm saying it's incorrect is because there's no other x on this side of the equal signs. Okay? The reason why you do that subtraction is so you can get all your x's on one side. If I drew a line dividing the equal signs up, I already have all my x's on one side. I have my 4x on one side and my 15x on this side. So since both of these are on the same side, I can combine them, which this will give me a 19x. And then I just bring everything else down. The minus is 65, the equals 11. And that's how my next line will read. Since my x's are all on the same side, just combine them. So now, we want to get x's all by itself. We got them all on one side, now we need to get it all by itself. So the next thing that I would have to do is actually add 65, because I need to move that 65 to the other side. So when I add that 65, negative 65 and plus 65 cancels out, leaving me with 19x equals, and what would equal? 11 plus 65 will give me a 76. So now, I want x all by itself. What needs to go? That 19 needs to go. So how do I get rid of 19? Since 19x is representing multiplication, I have to do the opposite, which is division. So I need to divide both sides by that 19. So when I divide by 19, I have x equals what? Hopefully you said 4. So are we done? No, we're not. We got x equals 4. We found x. Now we need to find y. If I go back to my original equations, let me slide this over a bit. So when I go back to my original equations, I already have an equation set up for me. It's set up as y equals 3x minus 13. And since I know what x is, all I'm doing is just plugging in that 4 for my x. So now, multiplication. So 3 times 4, that gives me my 12, minus 13. And 12 minus 13 is what? Is negative 1. So now, let's put it all together. My ordered pair, in this case, remember your x comes before your y, so it should be 4, negative 1. So that is the point of intersection. Okay? So if you take it step by step, you're still solving. But once you see one of your variables already solved for, it could be x equals, it could be y equals, you're going to take what's after the equal sign and you're going to substitute it in to the other equation and then solve for the given variable. Once you solve for that variable, you're going to take your answer and you're going to plug it back in. If you didn't want to use that equation that we used for number 6, if you didn't want to use this equation, you could have plugged it into the other equation. So you still got 4. I'm going to take this off here to the side. We got 4 for our x. So if I did 4 parentheses 4 plus 5y equals 11, we can still solve it for y. 4 times 4 gives me 16 plus 5y equals 11. Then I would subtract 16 on both sides. Then I have my 5y equals negative 5. Then divide both sides by 5. And I will come up with y equals negative 1. Isn't this the same thing that we just found? Yes, it is. So if you didn't want to use that other equation, you could still substitute into the other equation. Make sure it's the originals. And you will get the same answer. So just because when you do this work, and if your answer doesn't look exactly like someone else's answer, it all depends on where you started. No matter what, you should get the same answer regardless of the process. That's what I really should have said. So the process could be different, but your answer should be the same. Okay, so let me clarify that one. So if you got a weird answer and someone else got a right answer, and you're like, how'd you get that? I use this equation. It doesn't matter which equation you use. You should get the same answer. Okay? So what I did was after I did those 3 problems, the rest of the class did the remainder 3 problems. Okay? And that's one of the things I would like for you to try. And I think I'm going to try to put the answers to this on the next program. Okay? So after we did all those answers, all those problems, what we had for homework were these 6 problems to do. Still dealing with substitution. But this looks a little bit different. So I did 2 of the problems for them in class. And then they have the remainder 4 to do with their practice. So this homework assignment wasn't done for a grade. It was done for process. So if you stop and you're like, oh, I don't need that homework assignment, trust me, everyone needs to practice, especially with substitution. Okay? It's been a long time since you've seen it, and at the same time, you need to practice. Based on what I've been seeing in class, everybody needs to practice. Okay? So I'm going to look at number 2. And what's different with number 2? One of the equations is equal to x, and the other equation is equal to x. So both of these equations are equal to x. So as I mentioned in class about a couple classes ago, is when you have 2 equations equal to the same variable, you can do what's called setting them equal to each other. So instead of just having, I can do the substitution either way. I could substitute that 4y minus 5 in for that first x of the second equation, or I could substitute that 3y for the x in the first equation. So it doesn't matter. No matter what, both of those equations equal to the same variable. So now, we need to solve for y. So in order for us to solve for y, we need to get both of our y's on the same side of the equal sign. So as I mentioned before, we have 4y on the left side, and we have 3y on the right side. So since they're not on the same side of the equal sign, we need to get them on the same side. So you can take multiple ways of doing this. You could add 5 on both sides and then subtract 3y, or you can subtract 4y on both sides and go ahead and divide. No matter how you approach it, you should get the same answer. So based on time, I'm going to do my subtraction of the 4y. And when I subtract the 4y, I got a negative 5 equals a negative 1y. Okay? So since it's equal to a negative 1y, I don't want to know what a negative 1y is. I want to know what a positive 1y is. So in this case, I would divide both sides by a negative 1, which will give me my answer of 5 equals y. Okay? So now, I know what y equals. Don't forget, now I need to figure out what x equals. So now I need to look at my original equation. So when I look at the original equation, does it matter which equation I pick to find y? Hopefully you're saying no. So I can use the first equation, or I can use the second equation. My preference will be the second one, because I'm lazy, and it's a lot easier for me to get to. I'm not going to lie. So I have x equals 3y. But when I do this, instead of the y, I should put my answer of 5 in that spot. Okay? So I'm replacing it. Once I replace it, I have x equals 15. Now, if you don't believe that if I use this first equation, I'll get the same answer, give it a try. Okay? So now, I found my x, I found my y. So now let's put it together. What's my ordered pair? Remember, it's x, comma, y. So it should be 15, 5. So 15, comma 5 is my point of intersection. Okay? So now, let's venture to, I think I wanted to do number 6. Okay? So what's different this time? This time, I don't have a y equals. Or this time, one of my equation isn't x equals. So what am I going to do? Am I going to sit here and say, I can't do this problem? No, you can. Look at your two equations. If you notice with your two equations, I can solve one of those equations for either x or y. So hopefully you would say we want to solve this first equation for x. So if I rewrote it up here, I want to solve this equation for x, meaning I wanted to say x equals. So what is in the way of saying x equals? This 2y. So in order for me to get rid of that 2y, I have to do the opposite. So I have to subtract 2y on both sides. Once I subtract 2y on both sides, I'll have x equals 1 minus 2y. So that's what x is going to equal for right now. Just going to kind of box it in. So that's what x equals. I can take that information, this 1 minus 2y, and I can substitute it in for my x in that second equation. So that means when I rewrite it, I have 5 parentheses minus 4y equals negative 23. Inside that parenthesis is going to be 1 minus 2y. Do you see what I did? First, I solved that first equation for x. Because the reason why I did it for x is because x, there's nothing in front of that x other than an understood 1. Since there's no number, no different sign in front of it, I would solve that first equation for x. That would be the simplest way for me to go. Then I took that answer and I substituted in for the x in the second equation. So now, once I've done that, let's start solving. So again, order of operations. Please excuse my dear Aunt Sally. There's no exponents. We do have something in the parenthesis, but I can't combine 1 and a 2y. So now we got multiplication. So let's multiply. 5 times 1 and 5 times a negative 2y. So 5 times 1 gives me 5 minus 10y. Then I bring down the minus 4y equals negative 23. So if I may, I'm going to draw my imaginary barrier to show where my y's are. Are my y's on the same side of the equal sign? Hopefully you said yes. They're both on the left-hand side right here. So let's combine them. Negative 10y minus 4y. When I combine it, it should give me a negative 14y. Now, if you're using a calculator, please do not type in negative 10 minus a negative 4. Remember, when you're minusing a negative, it's actually changing it to a plus. And this is not what this is saying. Okay? That's saying a negative 10 minus 4, because we are actually subtracting the 4. Okay? So that's why it's a negative 14. Everything else is coming on down. So, my y's in this case are on the same side equal sign. So what needs to go in order for me to solve this equation for y? Hopefully you say you have to subtract the 5 on both sides. I'm not going to want to add the 23, because if I add the 23, will there be anything left over on that side? No. So 5 minus 5 will cancel out, leaving me with negative 14y equals a negative 28. So now I have to divide both sides by negative 14, which leaves me y equals 2. So we found y. Now we need to find x. So we're going back to one of our original equations. Okay? If I wanted to, I could use the equation that we calculated earlier. I could use that one because it's already set up for x. So if I do use that one, I'll have x equals 1 minus 2y. But instead of a 2y, I'm actually going to put a 2 for my y value. So now I have x equals 1 minus 4, which x equals a negative 3. So let's put it all together. So in this case, what's my ordered pair? It will be a negative 3, comma, 2. So those two lines in my original system, which is up here, they're going to intersect at point negative 3, 2. Okay? So we did those two, and I had the class do the remainder for homework. I just want to see their process. I want to see their thinking, because what I'm going to do is the next class, which is either the 17th or the 20th, we're going to look over our answers, and then we're going to progress to the next portion. Okay? So try the work. Try to follow the steps along. If you have questions, you have concerns, just email me. Okay? And we'll talk to you shortly. Thanks.